Hello everybody, glad to see you. Today we're going to talk about position control. We are going to have this component, we are going to have two holes here, and we have reference plane A here. Reference plane B is perpendicular to A, center to center of these two holes, and reference plane C is located on left hand side, and it is perpendicular to A and B. Here we have composite FCF. At top of that, we are going to have this large cylinder with a diameter of 0.4 perpendicular to A, back to B and C. These two large cylinders are highlighted in blue color. This composite FCF is going to represent a small cylinder with a diameter of 0.1, and we don't have any reference plane here, as we can see. It means we are going to have two small cylinders with a diameter of 0.1, and those small cylinders can be located in those large cylinders. And center to center of a small cylinder should have the value of this basic dimension. These two small cylinders can be anywhere inside of those large cylinders. They can be here, perpendicular to A, or they can be here, as you can see at top, and also perpendicular to A, or they can be located here at top, we can see, or here we can see at the bottom, or they can be in the angle respect to plane A, because we don't have any reference plane here. But if we are going to add A here, it means these two small cylinders can be anywhere in those large cylinders, but they should be perpendicular to A, and center to center of those two small cylinders should have the value of this basic dimension. In last step, if you are going to add B here, what happens? It means those two small cylinders should be perpendicular to A, and also we are going to have offset 0.1 respect to B. These two small cylinders should be in contact in the same situation respect to plane B. For sure, center to center of these two small cylinders has this value, this basic dimension, and we are going to have offset respect to B, and these two small cylinders should be in contact with plane B. They can be in this situation, as we can see, they can be tangent to that, or they can be in this situation, and also they should be perpendicular to A. Here I would like to highlight something about internal thread or external thread. Based on a standard, whenever we are going to use this positioning control, it means we are going to control pitch diameter of that threaded feature. As we know, we are going to have major, minor, and pitch diameter for threaded feature. If we don't write this minimum diameter, it means we need to have these special tools to control the position of that threaded hole. This special tools has this slot here in the middle, and in this way we are going to make contact for pitch cylinder for this controlling tools and this threaded hole. In that manner we are going to control pitch cylinder. But if we are going to write this minimum diameter, it means based on the value of minimum diameter of this threaded hole, control the position of this threaded hole. And in a standard, we can see what is MMC and LMC for that threaded hole. The same scenario can be repeated for external thread. If we don't write this major diameter here, we need to have special tools to make contact between pitch diameter of that measuring or controlling tools and this external thread to control the position of that external thread. But if we are going to write this major diameter, it is much easier. Based on the value of this diameter, we can control the position of that threaded feature. For now, I would like to close this session. In the coming session, I'm going to talk about symmetry. Thank you for today. I hope you enjoyed. See you next time.